Hi guys, we are taking a look at radians and degrees, and I just want to clear up a few things and make sure everybody understands about how to do those conversions, showing your math in a really good way. Okay, if you're taking science, you might have noted any sciences, chemistry, physics, bio, you may have noticed that, or even from grade 10 science, you talk about dimensional analysis. Okay, so that's kind of a scary word that really just means we are changing the units that we're using. So whenever in science that you heard the word dimensional analysis, it just means we're changing from one unit to another unit by using an equivalent fraction, an equivalent between those two things, so that we know those two things we end up with, those two numbers in different units, are actually equal to each other. Okay, so just like saying 10 kilometers, we need to change that to meters, say. We need to change that to meters. We actually are multiplying by an equivalent fraction where that fraction looks like the number one. Okay, we use that in math a lot to change the looks of things. Okay, the number one, as long as we're multiplying something by the number one, it actually doesn't change its value. Okay, so the number one. In this case, changing 10 kilometers into meters, and you could probably, a lot of you could do that just in your head anyway, but what's actually happening is we need to be able to cancel out kilometers. Okay, so we need to be able to cancel out kilometers like that. So kilometers needs to go in the denominator of this fraction. And we need to end up with meters, so we need to put meters in the top of this fraction. Now these two things must be equal. So the easiest thing to say is make the larger one 1. So 1 kilometer is 1,000 meters. So we're actually multiplying 10 kilometers by 1,000 meters over 1 kilometer. And then that will equal how many meters we have. In this case, 10 times 1,000 divided by 1. So we have 10,000 meters. That's exactly what we're doing when we're converting radians to degrees or degrees to radians. So let's go back up here to our two formulas. If we're converting from degrees, so we're starting with degrees, so we have however many degrees we have, and we need to change it into radians, then that means we need radians in our numerator of this fraction that we're multiplying by. We need to be able to cancel out degrees, so degrees must be in the denominator, okay? So we're actually multiplying, okay, so make sure you are showing math correctly. We're multiplying by this fraction. So however many degrees multiplied by pi radians over 180 degrees, that cancels out the degrees, leaves us with the unit radians, and then we multiply the number by pi over 180, and we get whatever number it is. I'll do a couple examples with you. If we're going in the other direction, we're starting with radians. We want to end up with degrees. Starting with radians, we want to end up with degrees. That means we need degrees to be left in our numerator. And we want to get rid of radians. That means radians has to be in the denominator, so those units will cancel. And this number here has to be equal to the number 1. And that number 1 is 180 degrees divided by pi radians, because those two things are equal. Okay? When we divide a number by itself, it equals 1. Okay, so this is called dimensional analysis. A big phrase that sometimes seems scary. It just means we're multiplying by an equivalent fraction to change the dimension that we're using to represent that same amount. Okay, just like we can change kilometers into meters, we can change radians and degrees by multiplying by the number 1 that is equivalent, makes those two measurements equivalent. Okay, so you had a couple examples in your part 2, Discover the Radians, in number 3 on the last page. So I just want to do a couple of those examples with you. We've got 5 pi over 6 radians. And a way to write down radians, do not just use r, because r in math means radius, okay? Radius, we know, is anywhere from the middle of a circle out to the outside of a circle. That's what r is, okay? R represents a radius in math. So don't just use radius. don't just use R, I mean, to represent radians. Radians is different than radius. Okay, radians means a measurement of an angle. Okay, so radians, measurement of an angle. We could represent radians by either writing it out, radians, okay, or you can represent it by using RAD, rad, okay, or the symbol for it, which isn't really used a lot, but sometimes is a little tiny C up here, okay? Make sure it doesn't look like a degree though. A degree is the little circle up there, okay? So radians is a little tiny C up there. All right, so to change this into degrees, so right now we're starting with radians, okay? There's my little C. Then I need to change it into degrees. I want a degree at the end. So that means I need degree in my numerator. I need C in my denominator. I'll use a different color here. I need degree in my numerator, C in my denominator, so that these units will cancel and I'll end up with my degree units. Okay, so what's the fraction here that actually is equal? This numerator has to be equal to the denominator so that it's the number 1. We're just multiplying by the number 1, and that's 180 degrees over pi radians. We need to multiply by that fraction, so please show your math correctly. All right, when we do this, we end up being able to, we get equals. We get 5. If you want to write it all out, you could say 5 multiplied by pi multiplied by 180 all over 6 multiplied by pi. So if you want to see it like this way you can see, because we are multiplying completely across the numerator, multiplying completely across the denominator, we're allowed to do that thing called canceling. Okay, so finding the number ones to reduce that fraction. So those can reduce. 6 goes into 180 30 times. So we can do this, and that equals 150 degrees. Okay, so going the other way. Let's see an example going the other way. 315 degrees, which is number F, 3F. So this time we're starting with degrees. 315 degrees. We need to multiply by a fraction that will let us have radians in the final answer. Okay, so what's that look like? We need to have degrees in the denominator this time so that these will cancel. We need to have radians in the numerator so that we end up with radians over here. And so the equivalency that we use is pi radians is 180 degrees. Okay, so we multiply again by that equivalent fraction. If you want to, again, you can write it all here together. 315 multiplied by pi over 180, and then reduce that fraction. It's going to have a pi in it. Okay, so I know 5 goes into both of these numbers. Let's see if anything more does. 5 goes into that 63 times. Did I do that right? 5 6s are 30. Got one left. Bring down the 5, 3. Yep. So this is actually 63 pi. 5 goes into 180. 3, 15, 3, 36 over 36. Oh, and I think 3 goes into both of those, so I can reduce that fraction further. So 3 goes into 63 21 times. So 21 pi over, and 3 goes into 36 12 times. Oh, actually I can reduce it further. It's okay if you end up doing this as well. And step by step, 3 goes into each of these, so 7 pi over 4. Okay, so 315 degrees is equal to 7 pi over 4 radians. Okay, on the next video, I'll show you how to write down the degrees and radians all the way around the units, all the way around a circle. And we'll talk about where we start measuring. Okay, see you in a bit.